Hey everyone, I hope you had a great weekend. So we are obviously in our next new week of distance learning. So we're going to start by going over the assignment that you had to do last week. So the two things that you had to do last week were quizzes and then this worksheet on review of compound probability. I wanted to walk you through this with video because you have a quiz. That's the next thing on your list for this week. So it's going to be kind of short and sweet this week. You're going to take a quiz. We're going to wrap up finally lessons 1 and 2, and then we will move on to lesson 3 for probability. Okay. All right. So numbers 1 through 6, it's asking about mutually exclusive events and overlapping. So mutually exclusive means they have nothing in common, and overlapping, which is the other type of compound event, they have overlap. They have something in common. Okay. So number one, the probability that you have ridden a roller coaster and that you've ridden a Ferris wheel. So would those be mutually exclusive? No, because there could be you yourself could ride a roller coaster and ride a Ferris wheel. Number two, you have brown hair and you have brown eyes. Those two things could happen at the same time. So are these mutually exclusive? No. That someone could be left-handed and right-handed. Now I know I have students who are going to say there are people in this world, but here's that could write with both, but can you write with your left hand and your right hand at the same time? I'm going to say that those are mutually exclusive, okay? So we see people write with either one hand or the left hand. For number 4, owns a classical music CD, owns a jazz music CD. Are these mutually exclusive? No, you could own both. That you are a senior or a junior, are those mutually exclusive? Yes. And has shoulder length hair and is male? Well, we can have some guys that have shoulder length hair, so those are not mutually exclusive. Okay, so I hope that helped a little bit in making sure you understand the difference between mutually exclusive and overlapping events. Okay. All right, let's go on to number 7. We basically are answering a question about what is the probability that a randomly chosen senior citizen chooses to vacation in Bermuda or in Costa Rica. So these, instead of giving you reduced fractions, they're giving the probability that you would pick someone in a percent, which is okay. So what we're asked to do is to find the probability that we randomly pick someone that chooses to go to Bermuda. And I would add that to the probability that they are going to vacation in Costa Rica. Okay, ignoring my handwriting. So since the vacation to Bermuda is 25%, and the probability that we would pick someone from Costa Rica would be 15%. Well, there's no overlap here because it was either they had to choose between Bermuda, Alaska, and Costa Rica, not they couldn't pick both or 3 of them. So therefore, we're just going to add 25% and 15%, and that means your final answer should have been 40%. Okay? All right. For 8 and 9, you've done or you've worked with this chart a lot in the past couple weeks. So I'm hoping I will fill it in, but I think most of you are getting really comfortable with understanding what happens when you roll 2 die and then you add up what you see. So the chart, there are 36 spaces. I'll talk as I'm finishing this. In this chart because you're rolling 2 dice. You have 6 across the top and you have 6 options. And so 6 times 6 gives you those 36. So here we have our chart is finished. So for number 8, They want to know the probability that you get an odd sum or a sum greater than 10. So the way that we deal with these compound events, there could be overlap or it could be mutually exclusive. So I'm going to do the probability of getting an odd. Well, if you look in your chart, that's half of them, but I'm going to leave it as 18 over 36. It just makes my math easier to reduce at the end. And then I'm going to add that to the probability of getting a sum greater than, that's the greater than symbol, 10. So the probability of getting greater than 10, well, there's only 3 right here. So I'm going to add the probability. But we do have overlap. So we're going to subtract the probability, and that says both. So we have to subtract away all the options out of 36 in our chart that are odd and greater than 10. Well, that's going to be these two. I'll use a different color. It's going to be those two, because 11 is odd and it's also greater than 10. So we're actually going to subtract away. So when we add our numerators, because our bottoms of 36 are the same, we get 18, 19, 20, 21 minus 2 gives us a final answer of 19 out of 36. And that does not simplify. So that would be your final answer there. Okay. Now, for number 9, you want the probability of getting even. Well, that's going to be half of our 36 spots, so that's 18 out of the 36. And then we need the probability of getting a sum of 11. Well, we just actually looked at that up above. There's 2 spots out of the 36. Now, you're not going to see me subtract anything away this time because this is not an overlap. A number can't add up to 11, and 11's not even. So when you add 18 and 2 for your numerator, your denominator would stay the same, and that's going to give you 20 out of 36. Now, all your answers have to be in simplified form. That means reduce it. So I think the biggest number that can go into both is 4. So 20 divided by 4 is 5, and 36 divided by 4 is 9. So your final answer there is 5/9. Okay? All right, let's go to the back page. We're almost done, and hopefully you're doing good on this, or it's helping. Okay? All right, for number 11, you actually had to make the Venn diagram. So for this Venn diagram, we know that there are 220 people involved in this problem. So your gut instinct might say, well, I'm going to put 104 in the pizza circle, but we can't. And it says that 82 used a credit card. And when it says half of the people who bought pizza used a credit card. So if we look at 104, half of 104 is 52. So that's going to be what we call our overlap. So 52 is what you should have put in the middle of your Venn diagram. So once again, I got that by taking half, because here it says half of the people who bought pizza used a credit card. That's both, okay? That's this symbol right here. That's your intersection symbol. So the intersection of pizza and CC for credit card is 52, okay? Now, if 104 bought pizza, we have to say, well, 52 plus what gives us 104? Well, that's 52. And then if 82 used a credit card, we would do 82 minus 52, which gives us 30. So right now we have our circles filled in, but remember there are 220 people. So if you take 220 and subtract away the 52 for just pizza, the 52 for credit card and pizza, and then the credit card, that's going to give us like what's left of the people that did not order pizza or use a credit card at the Italian deli, and that leaves us with 34. I'm sorry. So 34 you should have put somewhere outside of those circles. Okay? Now, let's answer the question. So we had to do all that work really to answer the question, which is the probability that a customer bought pizza or used a credit card. So we're looking for that they bought pizza. Well, that's 52 of them. 52 of them used a credit card or both. And then there's 30 that just use the credit card, but that fits into the pizza or credit card. So if we add up these numbers, some of you I noticed on your work were not given fractions. So I think what you were trying to do is just add up 52, 52, and 30, which is 134. But the problem is that you're trying to tell me the probability is 134. Remember, that has to be out of how many people or things you have total. So that would be out of 220. So 134 out of the 220 people that came into the deli used a credit card or got pizza. But if I divide this to simplify it, your final answer should have been 67 over 110. So let me fix that. So 67 over 110. Okay? All right, and then this last question was review. It really was not about necessarily compound events or, overlapping, but I just wanted to make sure. So you were using our Venn diagram, and you have to be careful here because if you look at the Venn diagram and you add up those numbers, so I want to make sure you're careful about this. I'm going to pull out my calculator as I'm talking. But if I add the 18 that just play field hockey, and then I add the overlap of 4, 3, and 2, and then just basketball is 7, just soccer is 10, but we have the overlap of 5, that only gives you 49. And I don't know if you realize this, but it asks 60 students. So you have to be really careful. This is not meant to fool you, but you really need an 11 on the outside here because there are 11 students that were interviewed that did not play any of these. Okay. All right. So since it's a review, I'll try to speed this up for you. So number 12, we are looking for the probability that we find a student that plays basketball and soccer. So that's the intersection. So the intersection of these two circles would be right here. So that would be 8 out of 60. And that simplifies to 2/15. Okay. Number 13, the probability that we have a student that plays football or basketball. So this is a union. That's the symbol for union. So we need everybody in the football and we need everybody in our basketball circle. Well, instead of adding those up, I'm just going to do 60 that we started with minus the 10 that only play soccer and the 11 that don't play anything. And so that gives me 39 out of 60. And 39 out of 60 simplifies to 13 over 20. Okay. All right. For number 14, that little apostrophe means not. So the students that do not play football. Well, we need to include pretty much everyone except for the ones that don't play football. So I'm going to use my little pen here and I'm going to mark off we can't include this, 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 or this. So let's see, we'd have a 10 and a 5 and a 7, which is 22, but then we have to add on the 11 up here that don't play any sport. So that gives us 33 out of 60, and that reduces to 11 out of 20. All right, last two questions. For number 15, we're looking for the union, which is that symbol in between the F, the B, and the U. So what's nice is we just need to add up all the numbers of what you see in the three circles. So if you add up all those numbers, that gives you 49 out of 60, and that does not reduce. And then our last question is supposed to be an apostrophe. It looks like a double, but this is not. So what's great is if you take your answer right here, those are the people that do play football or basketball or soccer. Well, there's 60 total, so 60 minus 49 is the 11. out of 60. And that does not reduce. And that's it. Good job.